So, continuation of the naming of organic compound. So let's talk about name, general formula, functional group, prefix, and suffix. So now let's start with alkane. So remember, we have done videos on alkanes, alkyne, alkenes separately to mention. So but now for alkane, we have discussed that the general formula is CnH2n plus 2, and the prefix and the suffix is A N E. That is, remember I said one carbon is met, two carbons is earth, three carbons is prop. So please watch the video on the first video to number 4 to cover up. So now alkenes. So for alkenes, we know the general formula is CnH2n. So we've discussed this, that you must have double bond. So I've discussed this. Then the suffix is ENE. So we have alkynes also. The general formula is CnH2n minus 2. Then we have triple bond. Please, if you have not watched the video on the intro, go and watch first. So the essence of this video is to write all the functional groups and their names, so that by the time we start naming, you will refer back to all this. But let's list them first. So alkenes, alkynes, and alkane. So the suffix for this one is YNE. Ine. So we have again alkanol. So we have alkanols. So for alkanols, this is the general formula. So it's all these general formulas we'll be using. That is CnH2n plus 1 OH. So that is an alkanol. So we have OH. Then the functional group will be if you attach OH. So by the time we start naming, you will understand the usage of all this. So we'll explain better. So the suffix is OL. That is alkanols. So we also have halogenoalkanes. Halogenoalkanes. So the general formula is CnH2n plus 1 X. So where X is halogens. Remember, the halogens are the group 7. So the functional group is X. So that X can be chlorine, it can be bromine, it can be iodine. So remember, all these are group 7. So in which their valency is 1. And remember, we use valency to write the structure. That is, the bond formed the number of valency of each element. By the time I start example now, so you will grab better. So halogenoalkanes. So if you have CnH2n plus 1 X, so the halogens are all these ones. So the suffix is chloro. For Cl, we use chloro. Br, bromo. So it's a suffix. Is a prefix. It comes before the name. And iodo. So that's how you write them. So the prefix, it doesn't have prefix there. So we have another one, alkanous. So alkanous, I've wrote alkanous before. So we have amino alkane, amino alkane. So the general formula is, you need to jot this down because we need it in naming now. So Cn H2n plus 1 NH2. So that is amino alkane. So the functional group is NH2. So the suffix is amino and the prefix is amine. So amine. So we also have alkanones. Alkanones. So the general formula is Cn H2n plus 1 CO Cn H2n plus 1. So that is alkanone. So the functional group is this, so CO. Then the suffix is ONE. So we add ONE. So now we also have alkanals. Yes, so we have alkanals. So for alkanals, the general formula is Cn H2n plus 1 CHO. So we have C. This is the functional group. So by the time we start example, you will understand all this functional group and the suffix and prefix. So the suffix is Al. So another one is alkanoic acid. Alkanoic acid. So the general formula is Cn H2n plus 1 COOH. So that is alkanoic acid. So the functional group is this. This is another O. So alkanoic acid. So we have H. So the suffix is OIC. So that is alkanoic acid. So we also have alkanoates. We also have alkanoates. So let me manage it here. Alkanoates or esters. Alkanoates or esters. So the general formula is Cn H2n plus 1 COO Cn H2n plus 1. You have to jot all this because in this video I will do part of the naming, so I will now continue. So I will be referring you back to all these name, general formula, functional group, prefix and suffix. So you have to write it. So alkanoates or ethers. So we have this. So the suffix is OATE. So that is alkanoates. So CO. Another one is cyano. cyanoalkanes. So cyanoalkanes. Clear the so cyanoalkanes. So the general formula is Cn H2n plus 1 Cn. So the functional group is this. The prefix cyano. So we also have alkoxy alkane or ethers. So alkanoate is esters, but alkoxyl alkane is ethers. So the general formula is Cn H2n plus 1 or Cn H2n plus 1. So the functional group is O and the prefix is alkoxyl. Then let me add one more. So can start the so you have to jot this. So let's say alkyl amide. So this is Cn H2n plus 1 CO. So you don't need to cram all this. So the more you solve, the better you understand. So by the time you name different compounds, so you know all these things offhand. Just jot it down for now. So alkyl amide CnH2n plus 1 CONH2. So the functional group will look like NH2. Then the surface is amide. So you will now know what is the usefulness of prefix, surface, and later. So now we'll start the naming. So jot all this down so it will help us in naming. So let's start with a name. Remember, I've told you that carbon have 4 bonds because the valency of carbon is 4. So what's the previous video? So now we'll be using the rules and the question to state the rules. Later we'll combine all the rules together. So now let's say you want to name this. So I'll only mention this. So in another video I'll start the name fully. So let's say we have this. So how can we name this? So before you name, you have to number the carbon forward, also backward. So by the time we see different questions now, you will see the usefulness of naming forward and backward. So in this case here, we have 2 carbons here. That means the longest carbon, the longest chain for this carbon is 2. So if we say longest chain, it means if I have carbon like this, So when you trace the carbon, as in without break, that is from here, you trace it like this is a chain. So let's say I have another carbon here. Now if you say you go this way, you can't go this way and also come like this, no. So to get the longest carbon chain, so you have to count this, as in this is a chain like this without break, or you count this way, this is a chain again without break. So if you are counting longest carbon chain, so you know which one you are counting. This is another one without break. So you can't go this way, come like this, then go back, no. So you must go at once. That is a chain. You count everything together. So you count this one too, that is another chain, then this is another chain. So that is how we can locate the longest carbon continuous chain. So now this is 1, 2, so we have 2 carbons here, and the number of carbons, the longest carbon chain, will determine the name. Remember we said met is for 1 carbon, et is for 2 carbons. So what's the first video? So now to name this, I have 2 carbons here. The longest carbon chain here is 2. So and for 2, that is et. For 2 carbons is et. So I'll now check how many bonds do I have here. I've discussed this also. I'll check the table I drew now. So alkanes, we have single bond. Alkenes, we have double bonds. And alkynes, we have triple bonds. Watch the second video so you will understand better for alkenes. So now since everything is single bond here, it means it's alkane. So and for alkane, you will just add the suffix. Remember we said suffix is after, prefix is before. So this is ethane like this. So because we have 2 carbons and a single bonds, so this is ethane. So let me start the full naming in another video. So I'll stop for now.